Welcome back to the next board. So now we are on board set number 4, and I had fired it up and I dinked with it a little. I'm not going to film too much at the beginning after our long repair on that last board, but things to point out where we're starting. This is a MDS-02 board, same as the other one. So lessons learned. We know Mario Brothers can only go on this side, and the board needs to be fully populated. So right now I got side 2 with pinball, validated set, and I have side 1 running with a, what do they call him? Skate Kid. Super Mario Brother hack Skate Kid. He's cool. I love him, actually. He's cool looking. I can't wait to kind of play that a little bit. But anyway, we have graphic problems out of the gate with Sky Kid. And if we coin up, we can coin up and we can play. See, we have, I'll try to play one hand. See, look at that. Woo, woo. And the graphics will kind of get worse. See, woo. We got things generating and populating where they shouldn't be. See that, like that weird scrolling action. Yes. So, what are we going to do? Lessons learned from the last one, and plus all... Oh, see, he's not even there. Wait, he's there. Okay, so we have graphic problems. Doesn't look like we have so much connection problem here. I revalidated before we started filming the first clip here. I checked all my ROMs again, because I have trust issues. They will die on you during testing. And it looks like we have good contact everywhere with the socket. So I think what I'm going to do, first thing off the bat, I'm going to remove the 2 RAMs. Now remember, this RAM is kind of a boot RAM. I'm calling him a boot RAM. If he didn't work, we wouldn't have anything on either side, or we'd have problems on both sides. So I'm going to stick here and here. Remember, the retro chip tester doesn't really test this guy out that great. But we're going to pull both of these just for the double check this whole side. I was going to say for shits and giggles, but just for validation that it looks like probably a RAM problem. Same kind of graphics weirdness that we saw, and it wasn't any of the other chips. You know what? Maybe we'll check these 04s because we know that they're kind of crappy. So I'm going to get off here. I'm going to check these 2 04s, make sure all the gates are working properly. And I haven't even probed around. I just really want to take those RAMs out right off the bat. Okay, let's go. Let's get to it. And I got the goot, the good old goot, fired up, warming up. All right, let's do it. Okay, we're back with this board. I removed the 6116 and the 6264. This checked out okay. This chip did not check out okay. So I went ahead and put sockets in and put the new 6264 chip in, this guy. Replaced him. I went ahead and just soldered it up, got everything clean. All right, guys, is power on. Will it fix it? Dun, 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 dun. Oh, we got boot action. Oh, Skate Kid looks kind of normal. Skate Kid looks normal. He looks normal. Yes, yes. I think that was the problem. Let's coin him up. Come on, Skate Kid. It's like Mario's cousin. It's Mario's cousin, Skate. Let me see if I can get that, all right. Let's roll. Oh. I think we're working, guys. I think we're working. I think we're working. There we go. Get that darn screen to cooperate. There we go. Maybe you can see what I'm doing. Trying to play one-handed. not easy. Oh, hey, you know what? I think we're in. I think we're in. Pinball seems to be running okay. Yeah, one bad RAM. So the sockets and everything are not giving me a problem on this one. How bizarre. And still the O2. All the colors look good. I'm going to let this thing run. Think about some other content for this board or this video. Yeah, it says works. Here's something else though. It says tested A-OK. Does that mean like tested, like, hey, everything is A-OK? Or tested side A is okay. But we got another cryptic message. Jumpers for gun installed. I'm going to have to look into that. I'm not familiar with any kind of jumpers for installation. But when I was inspecting the bottom of the board, here we have pins jumped. And I saw some other... I saw some other pins that... Oh, right there. You can see the flux on it. I'll put my finger by it right here. That had a jumper on it at one time. I think that jumper is gone. You can see the wire sticking out. And there... Okay, let's see. We got the double one there. We got that one there. Well... And then I think we had... There was another one. There's another... Oh, right there. Right there. There's another one. I was thinking there was one down here. There's one down here too, but I reflowed him. So hard to see now. Anyway, we'll look into that. I think maybe for this video. Maybe that'll be the thing for the video, to see what kind of mods required for guns at one point. But this is an O2 board. Who knows? Maybe that gun mod was only needed for the O2 rev. So, looks like Sky Kid is running okay. Looks like Sky Kid is running okay. Pinballs are running okay. We'll do some break. Oh, there's some. I do see some. Okay, that's just. I saw some flickering, but I think that was just the wires down here. All right, I think we're going to cut there. Maybe that will end the video. One RAM, one bad RAM. Remember what the graphics look like? Keep that in mind. If you see that, chances are one of these. First thing I did verify all the ROMs. Trust problems. Resocketed him. Actually, it's kind of like two sockets for that guy. Pinball's okay. Looks like felt like the controls worked. Yeah, shoot, we may just finish this one here. Now let me come back. Let me look into the gun thing and let me test it out. And I did do the voltage. Remember how we tested the voltage from the other video, from the first video? I tested all these. Set these all at 5. So maybe I'll just run down through and fill out the work order for this guy. See what's up with the gun and stop talking. All right, good. Easy fix. I like that. All right, see you later, Skate Kid. All right, let's get a wrap on this video and on this board. So let's jump right into it. Yeah, welcome back. It's a different day and a nice sunny day outside. Okay, so I got the game, the board, repopulated with Pinball and Tetris. And I think the board is okay. I don't think there's any need to do any further socket work or anything like that. It's running. I've had it running for a couple days. It's been pretty solid. So let's get into the final thoughts on this guy. So what I did, running a Tetris 4 ROM set inside 2 and versus Pinball. And we're just gonna pack it away and yeah, we're gonna pack it up like this, fully populated. Okay, so diving into some schematic stuff. So from my viewer, one of my viewers had a question about, in the prior video I made, about how the reset circuit mod, how it isolates the charging system. So actually it's not a charging system, it's just a circuit for the battery that feeds in here. So let's look at what I mean. So when I mean isolate the reset circuit, I mean logically. So this is your reset circuit IC right here. It's a quad one-shot latch, and these each side of these latches kind of work together to make your reset. So your main reset right here, you're looking at pin 13 of 1J, feeds into this hex inverter at 2K, and that makes your reset. That feeds all 4 reset circuits. Each PPU and CPU on side 1, side 2. So right here, you can control the whole reset circuit right here. So down here at 4C, where I want to start with this, down here at 4C, pin 5, now that's where they have the mod installed on these 02 version boards. And basically what they've done, they put a 2K resistor over to R3, which is about 3.7 volts. So they're tying this clear and that side of that inverted OR gate, they're tying it high. So basically, this OR gate kind of feeds this other hex inverter and a clear. There's 2 clear circuits kind of down the line, but these remain at a constant high. And then I think when that would reset, that resets off of that would reset that. But basically, coming back here, we're going to follow this line up, and you'll see what I mean. Like this, tying this high to 3.3 volts always ties that high, and then whatever the reset circuit's doing, that actually stays low. So one of these need to go high for that to go low or to go to high. Anyway, I know I kind of brushed through that. But it's about isolating this gate right here. So let's follow this line up to where I'm kind of going with this. So there's actually a couple circuits involved if you follow that line up. So we follow the line up from the reset circuit, and it comes to this little circuit here. It's a capacitor, a transistor I have yet to find. I found the capacitor, but not really these other things. I haven't really looked at it to that little circuit, but we follow it up. This is where we want to follow it up to. Okay, so now we get up here, and now we're back to our RAM boot up area here. Let me change that out so we can see it a little bit better. Okay, so that line comes up here from this transistor, and it's tied to the base of this transistor, which is, I'll just get you on it. It's right up here. It's right up here. That's the charging circuit area right there, right between those 2 capacitors, right there. This is let's see, where am I? That's the capacitor that we're looking at on the print. And we'll get back to these capacitors, and there's your dual one-shot. That's your dual one-shot IC. So let's go back and take a look what's going on. So basically, with that always tied to the 3.7 volts, it doesn't matter what this transistor is doing. That's going to remain high. But if we follow that back, if we follow that collector back and to the battery. So this is your battery, your RAM battery backup area right here. So if we zoom back out, that's in your battery pack here. And I put batteries in it too, so I wanted to see if it had any effect. But anyway, let's go back. I wanted to show you exactly what we're looking at there. Okay. So basically, when you have your batteries, you get like 3.3 volts from your battery system. And basically, this circuit here is just the power. It's just saying, hey, I've got power. Apply the power over to that RAM right here. This diode, that transistor, these resistors, and that diode. This circuit here is pulled high. So when you have power, it's feeding it's feeding this volts in right here. And that's why the voltage is always different on this pin. You have these diode drops that make the voltage less. Okay, so right now I have batteries in it, so we're actually getting 3.3 volts, and I think that's the whole thing. The 3.3 volts, what they're doing with that mod, kind of get this short, what they're doing with that mod, they're making that reset circuit think that this always has a backup battery installed. So always tie in that high. It doesn't matter what this circuit is doing. So logically, they're isolated. But I do believe if this circuit is healthy and your reset circuit is healthy, you shouldn't have any problems with your reset. So let's gonna probe around and let's look at these right here a little bit. Let's look at 4, 5, and 6 on the scope, and this bit. Let's look at this bit and this bit on the scope, and we'll probe around there, and I'll show you what those signals look like. Get this here where I can run everything. Okay, so let's probe around on that. Let's go to that 4C, 4, 5, and 6. 4C, 4, 5, and 6. Okay, pin 4 is the Q naught of that latch. So let's see, on 4. Am I on the right chip? Here we go. 4C, 4, 5, and 6. 4, 5. Okay, there's pin 5. That's where the mod is installed. So notice they have the jumper through, and they're getting with the 10K resistor, and they're getting about 3.6 volts. Now that's the same voltage, about the same voltage that the battery would supply. So let's go to pin 4 of that. Oh, I lost my way. Pin 4. 1, 2, 3, 4. Okay, so pin 4, that's the knot of the latch, the main latch that runs the reset. So its partner, its flip over here, he should be low. Oh, I'm on the wrong chip, guys. 4, 5, and 6. Let's just go back to 4, 5, and 6. The inverted, not gate, and then the output. So see, yeah, the output is low, and you need that output low because it goes through a hex inverter to go high. So I'm gonna reset that circuit. So let's reset it. Let's take it low on pin 4, and you can see. 1, 2, 3, 4, 5, 6. I need to be on pin 6. Now let's ground pin 5, and you can see I ground pin 5 and it activates that gate. Now pin 4, kind of the same thing. It's low, it's going high. 4, 5, 6. Yeah. So a high or low on either one of those in that tied down state will cause that gate to switch or activate this guy. Yep. So we just probe on right here, and then let's go. What else did I want to do? I just thought about it, like kind of looking into that. I did want to do a battery check. So let's kind of keep on the scope there. I'm gonna probe on D9 over here by the battery or the backup RAM. So that should be our voltage coming in to that resistor. Let's power down. We're gonna power down. There we go. We have about 3.4 volts. You can't take super accurate readings with the scope like that, but let's go on the power pin of the RAM. See, we're getting about 3.3 volts. So that with those batteries being in, that circuit's working and it's getting power all the way to the RAM here. So, and then I guess let's power back on and look what happens. I'm going to keep on that power pin. So then it just bumps up to the full 5 volts of the board. So, not that the batteries were used for much, I guess just for bookkeeping and not too much of saving, but I still want to make sure that those circuits are all okay. Kind of go back to the print. What else did I want to show you on that? I think that's about it. We could probe around all day on this reset circuit, but we're just going to move on. So that's what I mean about that mod. That mod logically isolates those two circuits. I think if that guy, let's go back down to the print. You know, oh, it couldn't be a short video. So I really think if that guy right there was able to go high or low, you would have false triggers, I think, between that battery circuit and here. And then I have another note here. So the one board had a 0 ohm resistor from pin 6 of this 2K right to ground. So that was another way they isolated that logically. They just took it to ground right there, and it isolates that whole circuit. Boom, done. So you could put a reset circuit in here or something too, but it's not that hard of a circuit to troubleshoot. It's really just some gates, that one-shot IC, some resistors, a transistor or two. Yeah, easy circuit to keep the reset here. Okay, so let's switch gears, man. I didn't want to spend that much time on that. It's not about time. I wanted to give a good answer. So let's go back to the bad RAM here. I wanted to do a little bit more on this. So this is the bad RAM that we found according to the retro chip tester. So going through, I'm going to make this quick too. I don't think there's as much here as I thought. I want to look at the pinout for this RAM. And my thought was that the 5533 is not the same as a 2764 with a couple pinout differences, but it is a drop-in replacement. So let's go down through and just look at some of the differences. I don't know if it's a typo on this memory data sheet, but anyway, pin 2 is address 11 on the 5533. Now pin 6 is actually kind of weird. On side 1 it's pulled high, and on side 2 it's pulled low. So that's not even really an address line anymore. They're just pulling it high or low. And it might have something to do with the command and control, the master-slave thing, how the board knows what mode it's in. All the other address lines are okay, data okay. Just made a note that your chip enable is tied to ground. And now over here, pin 23 is now A4. And that's where I thought with the retro chip tester, it might have problems with 11 being up here and 4 being over here, and then pin 6 being a ground or whatever, or a high or low. These address lines are okay. On the 2726 or 2764, showing pin 26 as not connected, but it's actually enabled to on the board itself. So keep that in mind. Programs actually write enable and like that. So I did make some notes of the changes. So what I did, I made a little adapter to jump those pins, but this adapter is null and void because I jumped the wrong pins. I thought it was pin 6 and pin 23 that were exchanged, and where it's actually pin 2, address bit 11, and pin 23 over here. So, but funny enough, these still fail. And funny enough, I'm not going to do it just for sake of time. Funny enough, with that adapter, the 2764s will still pass either way, straight in the retro chip tester or with the adapter there. So more on that. We have plenty more boards, so I'm not going to get too much more hot and heavy on this board. It's a 15-minute wrap-up, longer than the whole video. But wanted to cover, again, about the reset circuit and the question, and cover a little bit more about that RAM. So I guess I bust through that. So that RAM, and actually my point is on that, even with the address bits being in different positions, both the game and the retro chip tester recognize that as they're addressing, writing, and reading back. It don't matter, I guess, those two pin positions. because it's still addressing all of those blocks kind of in order, not maybe in perfect order, but everything's still getting addressed, written, and read from the same locations. So if there were bad cells in the RAM, it would still fail. So, long wrap up there. Sorry guys, but this has been a fun board. I can't wait to get to the next one. This is the last 02. The next board will be an 03. So we're gonna have fun. I'm gonna spend the rest of the day playing video pinball, which is a very fun game actually, and the Soviet mind game. All right, guys. As always, thanks for watching. I hope you learned a little something.